Hello.
Hey, what's your science question?
How do you think the galaxy was formed?
Yeah, this is a mystery. This is a big question. Um, well, we know that galaxies are made of stars, but
Yep.
stars are actually maybe 10% of the mass of the galaxy. In fact, most of the mass is in the form of dark matter. So, in the early universe, it was mostly made of dark matter, and that's what really seeded the galaxies to form that way. Dark matter is invisible to us; we can't see it directly, but it's there, lurking, and it kind of attracted stars and gas and dust around it and formed the first galaxies.
Okay. Do you think at the rate of how climate change is going, you think the Earth will still be able to sustain life in like 100 years?
Yes, yeah, climate change will not extinct us necessarily, but it will harm us in many societal ways. It'll stop food production. It'll wreak havoc on food production. It'll make going outside very hard, working outside very difficult. It'll make many species go extinct, but life as we know it will still continue as we adapt and evolve. But if it gets too bad, sure, it could cause an extinction, but it likely won't get that bad if we simply wean off of fossil fuels, start using solar and wind and all these things. They will definitely help for the better.
All right. Those were my questions. Thank you.
Great.
Hey, how you been, bud?
Hey, how are you? Nice to see you.
All right. So I came in when you had I think he was like two ahead of me, where he was asking questions about gravitation from the moon to the Earth, et cetera, et cetera. I kind of wanted to clear up on that because we do have some really cool specifics. So when he was talking about leaving the gravitational field of the Earth, that's not what happens. When you're going to the moon, you're still inside of the Earth's surface of influence, is what it's called. So
Hmm.
every kind of celestial body has a surface of influence, and this is the zone in which its gravity will start to pull you in. If you're heading towards it. So when we go to the moon, that's only about 250,000 miles away, and its surface of influence is about a sixth of that. So like 2,000 ish, or excuse me, 26,000 ish or so miles out. Whereas with the Earth, if you wanted to get out of the gravitational field of the Earth, you're going to go way past the moon. You're going to have to go out about 412,000 kilometers
Right.
just to get out from the Earth. So that's the whole thing with how gravity works and how orbits work. You're not falling around the biggest thing. You're falling around the closest thing to you, as long as that thing weighs more than
Right.
you and is in a stable orbit. So I just kind of wanted to clear that up a little bit. And I can hang out around a little bit if you want more physics answers.
Yeah. Thank you. Appreciate that.
Yeah, I'll mute out until you need me.
Thanks. What animal has the potential to be smart as humans? Well, probably other bonobos, chimps. Hey, what do you got?
Hey, what up? How are you?
Great.
I just don't see your facts about anything, to be honest.
What do you mean?
Like yesterday, like I saw your video about God is not real, blah blah blah, all that BS. I I think you're BS right here. Thank you.
Great.
Bye.
So go ahead, educate me.
No, no.
Okay.
I
Have a
might
good day.
buy you if you're right.
Hey,
Hey, what do you got?
a few questions on special relativity and general relativity.
Okay.
So, general relativity is how gravity affects time, right?
Um, no, it's how space and time itself warps.
So it's how it's how gravity warps space time.
Well, mass. mass warps space-time, and that's what gravity is.
So, I heard like an example for special relativity where like there's a paradox because like the faster you go, like let's say you're in a rocket ship, the faster you go, in your perception, it looks like that the people on Earth are going fast because you're moving at a certain speed.
So general.
And
Yeah, well, time is that's called time dilation. Time is relative. From my perspective, if I were to go in a rocket ship and go half the speed of light, nothing would change about my perception of time. Time would be ticking the same as I see it now. But relative to somebody on Earth who's watching me from afar, they will see me as being slow. Because the faster you move through space-time, the slower relative you are to somebody else that's not that's stationary, well, relatively speaking. Again, everything's relative. Motion is relative, because in actuality, special relativity shows us that everything in the universe is moving at the speed of light. It's just that some moving more through their spatial dimensions, some other more through their temporal dimensions. And that's all special relativity shows us. And that's why it seems like time changes. Hello?
Can you hear me?
Yeah, what do you got?
So you're always like big on evidence and proof and truth and science. So why do you support trans people?
Because they're not doing anything wrong. They're just existing.
But they're delusional. You realize that, right?
No, being trans is not a mental issue. It's perfectly natural and normal. It's just a neurochemical thing.
You can't just decide one day that you're a woman when you've been a man your entire life.
Yeah, you don't just decide to change your gender, right? It's something that you're born with, neurochemically. Just that when you're a society that says you have to be certain ways, and you recognize later on in your life that you don't fit in with that category, you just align your gender with what you think you are, your preference.
What you think you are, but what are you?
Gender is a social construct. It's just a way of us describing, how we want to behave or express ourselves sexually in society.
But what were you born? That's what really matters.
Chromosomally, if you talk about your chromosomes, yeah, of course, there's male and female, but gender is not chromosomal, right? Gender is something neurochemical. It's like, imagine your brain putting a male brain into a female, right? There's nothing wrong with you. It's just that your brain is different. It doesn't mean that there's anything wrong with you. It just means you have a different brain than somebody else in their respective sex.
So your answer is just however you feel. That's what you are.
No, that's a huge straw man. But I explained to you that there's a difference between sex and gender.
What makes them different?
Gender, like I said, if you're listening, a social construct that depends on your neurochemistry. Sex is chromosomal, depending on your biology.
But how does society construct gender?
Societal norms, right? Typically in America, we think of a woman as someone who has long hair, dresses a certain way, likes pink, Barbies, right? It's all just societal.
But there's men who like those things too.
Okay, if they like them, then they like them. What's the problem?
That doesn't change your sex though.
Well,
just because you like certain things.
Well, if their neurochemistry aligns with what a woman would be like in our society, then they would call themselves a woman. That's it. It's that simple. I don't know why this is so hard for people. It's just a gender, right? It's just a pronoun.
Okay, whatever floats your boat. I mean, whatever helps you sleep.
So why do you hate? Why do you hate them?
I don't hate them. I think they're delusional.
Why? Prove it.
Prove they're not.
Well, there's no mental illness. Where's the element? There's no illness. They're just normal people. They're not mentally They're not mentally ill at all. They're not. They're just like me and you. There's no element there.
So if I put a police uniform on and a gun on my hip, and I think that I'm a police officer. That wouldn't make me delusional.
Well, now you're talking about a like actual different. There's a difference between a police officer, sir, and a gender, right? Gender is a mental. It's a social construct. It's not a real thing. Like it's not like a police officer has a badge and actually has done training. Right? Of course, you'd be delusional there. But when it comes to gender, right, gender is something that we invented to, fit in with a certain preference as to how we want to live with each other. It's not an actual real thing, like a cop is.
Well, cops weren't a real thing either until we invented them.
Well, the
Right.
point is that cops are real, and gender is just a social construct.
We didn't invent gender.
Yes, we did. Genders are just how we prefer to behave or act in society.
Okay, well, that's your opinion.
No, this is like neuroscientifically accurate, right? We have tons of research on this. We have investigated trans people brains. There's just nothing wrong with them at all.
All right, well, Jesus loves you, Michael. Have a good night, okay?
There's no evidence to Jesus. And if he loved me so much, why does he want to harm people like LGBT, the LGBT community? Why does God want to send me to hell if he loves me so much, right? Your God doesn't love anybody. He pretends.
Okay.
Hi, good morning.
Hey, what do you got?
How you doing, fella? You all right?
Yeah.
Yeah. Just a quick comment on that other guy who came in about, quoting about Jesus, etc., and trans. I absolutely agree with everything that you've said. And big respect for you. My partner is trans. She's fully trans, and she's a human being just like anybody else. She has feelings, she has emotions. Just because people are so judgmental doesn't make that person a horrible person. It's only 1% of the entire world that are transgender. It's a very, very, a minority of people, a very tiny few, but that so hated on it. It's so wrong.
Right.
But I just want to I just want to pick you up for, for what you've been saying. I think it's absolutely brilliant.
Thank you.
Big respect to you, man.
Yeah, thanks.
You're welcome. You take.
Hello?
What's up?
Hey, what do you got?
Yeah, I mean, I've actually been in these lives for a while, so I sometimes actually do learn a lot, and I actually do have a question, not like in an argumentative way, but for me, I feel like I am becoming more atheist in a sense, because just all throughout when I was younger, when my parents would bring me to the mosque, like I just didn't really agree and I just never really believed why is there like one religion.
Great. I'm proud of you. Now, do you have a science question today?
Yeah, my question is when people ask me about why are you atheist, what do you think they ask me is the Big Bang really what you think happened? And I say yes. And then they're like, what created the Big Bang? I guess I want to know how to better answer that question or like that argument.
Yeah. Very simply put, the Big Bang's not the beginning. It's not the creation. It's not an explosion. Right? The Big Bang is simply referring to a moment in time where the universe as we know today was smaller, hotter, and denser. And from that moment, right, we call it rapid inflation, it expanded rapidly into the larger universe today. Space and time itself expanded rapidly. It stretched apart. That's all. That's all the Big Bang means. It's that simple. It's not an explosion. It's not creation. It doesn't mean that exploded and then we just magically appeared. Not at all.
No, thank you for that. I didn't mean to yap for the comments, but I know that there was like 2 days ago, someone asked you, like what happened before the Big Bang. And I think something you mentioned I was thinking about was when you said, why does there have to be a single starting point? Like, and that was kind of true. Or I think you also said, why does there have to be a single creator? Why isn't there multiple? So I always, that actually helps me understand that question more.
Yeah.
So.
Look, we don't know. See, the theist is assuming that we know everything because they have the Bible that says it. But unfortunately, we don't know the answer as to what caused or what was before the Big Bang, if that is even a valid question. But the point is that if there was a before, well, it could be something quantum, like a quantum field or something like that. And if the Big Bang isn't the start, well then, right, the universe always was. And you don't need God either way. You don't need God anyway at all.
Yeah.
Thank you for that. Because I'm just thank you. Because I'm trying to think of ways. Because my family is Muslim, and that's how it's. I don't mean to argue with them or convince them, but I just try to think of like their counter arguments. Like if they say, I don't know, it sucks being. I don't know. It sucks being like criticized or feeling like worried to like even say these things out loud. But I do feel like there's not evidence that points to the Quran being like the religion or the Bible being, and that's the argument I've always used is like there's not like one, there's not proof that one single religion, like why would you laugh at Zeus existing but not God is like some argument I use. But yeah, I guess I was just looking to see the science-based part of it, and I appreciate that you answered that.
Yeah, you look, don't get too much crazy with your family, right? They're never, unfortunately, some people are never going to learn. It's just a fortunate fact, right? When I like during the holidays, I don't argue with my grandma about God. Like that's a waste of time.
Yeah.
So I don't talk to my grandma about this, right? It's like, no, right? So that's how I view family. They're never going to change. Why make it worse?
Yeah, they're not even looking for, they're not even looking to learn. So no, thank you so much. I'll let someone else
I
come
will
up.
suggest that you engage with other people that are like-minded.
Yeah.
Using social media is a good way to do that. Does science succeed in creating life from non-life?
Yo. I got an interesting question, a science question. Okay, so AI. Do you think AI can exist? Do you think we can make AI exist in a digital world where it advances by itself and continues to so on and so on?
It already does. We already have AI that advances itself.
Yeah.
Just slowly at the moment.
Good, cool. So do we think like it can eventually exist beyond our capacity? We're not even realizing it's going on. You know what I mean?
Yeah. So we have ChatGPT. We have GPT-4. They're working on GPT-5, and we know that Google just announced their DeepMind project.
Cool.
Where
And now,
it's more advanced than GPT-4.
another
And
question.
when it comes to AI, we know that these neural networks have certain numbers of parameters which are equivalent to synapses, right? Neural connections. And already GPT-4 has, I think, maybe a few hundred billion parameters.
That is crazy.
Our brains are at like 6 trillion. So we're about 10% there of reaching human, it's called AGI, average general intelligence of a person.
Now, the second part of that question, not to mean to cut you off, just to be quick. So now, if the AI could you think the AI could continue to learn if humans went extinct, but there's still some source of power somehow, some way, the AI that was initially built evolved, and there's people like me and you talking on there. You know what I mean? In their own realm or something.
The possibilities are endless with AI, with artificial intelligence. It's very, very plausible that there's some kind of stuff already out there that exists already.
And then the last part of my question is, do you think there could be two people in AI saying, who's our creator? And then how would they ever see us?
I'm sure that AI will develop their own religions if they become smart enough to do so.
And we created them. But if they had conversations saying, how can we find our creator? But they would never be able to see us.
Well, I mean, they could. They could see us. But creator doesn't mean anything. Like, in scientifically speaking, creation doesn't happen, right? Nothing's ever created. But the point, that's a very ambiguous word. But yeah, AI will become smart. It already is smart, and it will perhaps change the world.
Down a couple of years back because they had two bots that they were testing, and they started responding to each other in a way that Google couldn't understand and faster than Google could even keep track of. So they had to shut it down.
Yeah. So you compare AI and you combine AI with quantum computing, it's over for us.
Unless we become it, right? We're making AI so we can step into the shoes of AI and digitize ourselves. That's one thing. Like, that's how we could survive. But yeah, if we make it just on the planet and no way to actually become it, yeah, we're fucked.
Yeah. Hey, Lexi?
Hey, so I've tried to understand, like, higher dimensional like things whenever we're talking about like fourth dimension. And from what I understand, if a four-dimensional object passed through our three-dimensional plane, all we would be able to see is somewhat of a three-dimensional shape that would come and then disappear.
Be kind of
Yeah. So if I had a three-dimensional apple, right, and I plunged it into a two-dimensional world, a flat sheet of paper, on the paper, it would see a two-dimensional thing, a two-dimensional aspect of that apple.
So
But
what
in
if
a four-dimensional way, if a four-dimensional object came through the 3D world, we would see, yes, you're correct, a three-dimensional object. It would be coming in and zipping out. Yes.
right? So what if that object wasn't just passing through our plane and it actually existed? A four-dimensional thing actually existed
Yeah,
within
we don't know
our
what it would be
three-dimensional
like.
plane.
Yeah, there could be higher
Would it
dimensions.
would it maybe look like a dark thing that light can't escape from, and we don't actually know what the
Yeah,
parameters are?
this is the thing about relativity, right? There's higher dimensional things, aspects about the world that we just don't have access to, and this is what string theory is trying to attempt to do. This is what many different theories of quantum mechanics is trying to do.
I saw like an article recently where a black hole was like basically recorded spitting out gaseous like trails that ended up forming stars, which is a little weird because nothing's supposed to be able to escape, right? So we don't like really understand the physics of what's happening within black holes, but would a four-dimensional object hold more mass within a smaller space than a three-dimensional object? Meaning, could a black hole be half the size of our known universe, even though it appears to us as something not as big as the things around it?
we don't know what matter would look like in a fourth dimensional state, so we can't really talk about that. And then on the other side of that, the jets that you're talking about, those probably, it sounds like you're probably talking about gamma ray bursts. And what's happening there is it's not from the black hole itself. It's not something that's beyond the event horizon. This is particles in the accretion disk that have become so charged with their velocity that their angular momentum will not allow them to fall into the actual event horizon. So they end up riding it towards the poles in a kind of a weird spiral. And then once it gets to the tip of that pole, it's emitted as that beam, those gaseous, very high charged particle beams. And those are actually the brightest things in the universe that we know of, other than the Big Bang herself.
Spits it out from both sides too, both axes.
From both polar vents. So you'll get a beam going in one direction and then a beam going in the other direction, wherever its north and south poles are.
Hello.
Yo. Yeah, I just wanted to ask you a question, Mike. I wanted to know, like, how would the human society, like, from today, how do you think it could, like, progress? Like, when what I mean by this is, like, obviously today we're like really advanced. We have cell phones, the internet, fast like planes, all that. And then like when you're thinking like 100 years ago, right? No one could have predicted we would be this advanced. It wasn't like this. Obviously phones didn't exist. Everything was on paper. So I just wanted to see like, I just want to ask you like 100 years from now, something like that. How like do you think things like, I don't know, hydro cars or like we can like use our minds like for digital things or live on like other planets, stuff like that?
Yeah, technology. The way technology is progressing, it will be exponential. And you thought 100 years, from 100 years from 1900 was crazy. Well, the next 100 years is going to be even crazier. There are going to be all kinds of things we couldn't even imagine today existing. So I can't speculate too much there, but I will say that the trend today is going towards quantum computers. The quantum world is, we have really just begun learning about it now, It's going to open up more in the next 100 years, right? The key to everything is the quantum world. That's really the key to the universe. So, the more we learn about quantum computers, the more we'll learn about the rest of it. And perhaps we'll have time travel. Perhaps we'll use wormholes. Who knows what we'll have? But I think that consciousness itself will change. We'll probably be able to beam our consciousness to other planets, like Avatar. Avatar is a real plausible thing, where you beam your consciousness into a robotic being and you live anywhere you want to, at the speed of light. But these are all possibilities within the realm of physics that we just don't know if it's possible today. But we don't know if it will happen in the future, but it's possible.
Yeah, honestly, that's kind of
It starts
sad.
with factory farming first. We do that, and
yeah, in the shorter term, I think that the next 50 years we'll see probably nuclear fusion emerge. We'll see more quantum computing. AI will be the most prevalent in the next 50 years. I see factory farming going away. I see lab grown meat being more prevalent. I see cars becoming purely electric. Everybody will have electric cars, batteries getting thousands of miles on a single charge, solid state batteries. I see a lot of new technologies come in.
Yeah, I think like eventually we'll be in a society where there's just everything's replaced by robots, and it's kind of crazy how like that probably won't be for a while. So like we'll just all be like dead. So I think that's just kind of sad to think about. I also wanted to ask you about.
Well, the thing about that, I used to think that way too. I used to think that it's sad that we'll be gone, but that's how life happens. That's how new things are learned, right? That's how we progress. If we want progression so badly, we have to be able to let it go. We can't just always get what we want, right? And so our descendants are the ones who will be going to the stars, not us necessarily.
Yeah. And I just want to ask you a final question. What about like hydro cars? Like there's, we have a lot of water here, so I feel like a friend once told me that I don't know, it could be like like a $1 trillion idea, but I don't know. That's what
Hydro cars that work on water. That's not enough energy in water, right? There's not enough energy in water for us to power cars and stuff. We electric batteries is the future by far. Batteries, and beyond that, fusion. But people don't realize that there's so much power in things like solid state batteries, graphene batteries, where you can get literally thousands of. Imagine having a phone that you never have to charge again because the battery's so efficient. That's the future.
Like water would work. It'll work. Like you can do short trips, but it's going to take you like that whole goddamn tank to get across town.
Oh, well, I'm not saying it's bad. I'm saying that technology is adopted if it works efficiently, quickly, and easily. I don't really see water cars being that easy and good.
Not like thorium and graphene. If we can figure out thorium and pairing that with the graphene, then you're totally right. Like that's what we're going to use for everything, because you're talking about a 10,000 year charge on your car with half a gram of thorium and maybe 14 grams of graphene.
Right. Yeah, exactly. We can get to a point where the energy is so efficient that having one battery will last you a lifetime, and perhaps multiple lifetimes. Yeah. Any other questions?
Oh, okay. So, yeah, like everything we've talked about, if we're regarding like climate change, right? Can you give like an estimate on like how long the Earth can sustain like the human effects and like how we're kind of like destroying the Earth?
The thing about climate change is that it's not a quick thing. It takes time, right? It's kind of like a boiling frog in a water pot, right? You turn the heat up a little bit, it doesn't notice it. It thinks it's a jacuzzi, right? A little bit more, oh, it's nice, it's hot. And then before you know it, he's boiled. That's kind of like what we're doing today. We're kind of the frog in the pot being boiled slowly. And we will note the saddest part about this is that we'll notice the changes become worse and worse through time, and it will affect the most impoverished among us the most. People in Africa, farmers will be hit the most. Crop yields will go down, water resources will go down, right? We'll see ice melting across the world, glacier melt. It will be bad for us, but it won't affect us immediately. It won't just wipe us out in one day. It will. The worst part about climate change is that it's slow. That's the worst part, and it's compounding. But do I think we'll survive it? Yeah. It's just that, it's going to be a different world than today. But who knows in the next 100 years if we have the ability to fix it all, or I don't know. But the way we're going right now, it's looking very bad for us, and it doesn't seem to be being fixed urgently enough.
Yeah, if things keep going the way they are right now, especially with something like factory farming, you would think that that's the easiest thing to get rid of. But no. Within 100 years, if we keep this up, we won't even make it 50 years. Like we're going to be poisoning the atmosphere so bad that it's going to release the big methane wells below the polar ice caps and then the shallow.
Yeah, there's a lot to worry about, but
yeah,
again, there's a lot of possible solutions. And if we're urgent enough, they might be able to be fixed. But if we don't fix them, we're fucked. Yeah. Any other questions, Ian?
Nope, that's it. I appreciate you guys. Have a good day. Night.
Everybody, please subscribe to the YouTube.
Hello.
Hey, what do you got?
Hey, what's up? And I came to ask you a question about evolution. Scientists don't really know, the reason why fur originated. Why did mammals and how did mammals truly come about? We don't really know.
Wait, you said fur or mammals?
Yeah. Both. We don't really know why fur, came about or originated.
Mammals
and we don't know how mammals came about.
Mammals emerged from the reptiles, right? They branched off the reptiles about 260 million years ago. The reason why fur is because as the climate changed, the Earth's climate got colder, right? 300 million years ago it was warm. Then as the world got colder and mammals migrated across the Earth into Asia, where it was colder, right? Siberia, Asia, that area, Eurasia, it was colder. They needed to adapt, and fur was that adaptation that helped them survive. Whereas reptiles don't need that, right? They're cold-blooded, they don't need that. The parameters in which they exist are very, very warm, but mammals, chose to survive. Also, the impact of the dinosaur impact about 66 million years ago, that pushed other mammals to become monkey-like, live in trees, and become like our ancestors that were apes.
Yeah, okay, I understand that part, but so you saying it was like colder, because isn't like the first, I think, fossil record of a mammal, it looks more like a rodent.
By the way, many reptiles actually have fur. Some reptiles do have fur, like the dinosaurs.
Oh.
They had fur.
So
it's clear that the genes that enabled fur existed within dinosaurs as precursors before any mammals even existed.
And they're made of the same thing. Your hair is with a bird feather. It's the same kind of character.
Right.
So were dinosaurs cold-blooded or warm-blooded? Because reptiles don't have fur.
They were neither. They were actually, I forgot the name of it, but they were in between. They were, I forgot. Do you know God Killer?
Not offhand. I can't remember the actual scientific
they weren't
term.
necessarily cold. Maybe perhaps a few of them were cold-blooded, but
most of that was the hardcore reptilians. The hardcore reptilians, because dinosaurs kind of were in this center area. So about 260-ish million years ago, you have this kind of weird branching from the true reptiles into mammal-like reptiles and dinosaur-like reptiles. Right. And then the dinosaurs kind of become the dinosaurs from that secondary branch, and we kind of become mammals from that primary branch there. And reptiles kind of just stayed what they were because it works really well in warm areas.
Any other questions, Osiris?
Oh yeah, I got one more, just one more. Like when it comes to like reptiles, why is it that mammals don't seem to get as big as reptiles? Reptiles got huge, well, dinosaurs, but you don't really see any mammals that compare to their size. Why is that exactly? Except for the blue whale.
Yeah,
That's
it has to do with the physiology. So dinosaurs have weird, very, very hollow bones, and they had air sacs in them. A lot of dinosaurs, like the largest ones, had air sacs, which made them able to become bigger. Um, I mean, obviously, there's natural selection going on where the tallest ones survived. The ones that were herbivorous that can reach the tallest trees survived more. But they had a very different physiology from mammals in the sense that their bones are very hollow, and they had air sacs in them, which allowed them to be lighter on their feet but still bigger. These are some of the reasons why.
The atmosphere too. If
Okay,
you have
thank you. That's
percent more oxygen in 70 million years ago atmosphere Earth than
Right.
you do today.
Yeah, there's many different reasons, but oxygen was one of them.
okay.
Oxygen
That's it.
helps the
Thank you very much. Nice
metabolism.
talking to you. Nice
Yeah.
talking to you.
Hello. Just first off, I'm just on my girlfriend's account just to obviously clear that up.
Okay.
But one question I had is how exactly are these years, like how do people come up with these years for like dinosaurs?
For what?
For dinosaurs to say like, oh, this we picked up this is this so many million years old. How do you find that?
So we can date fossils. We can look at the geological strata. These are layers in the earth where we can understand, we can date the surrounding rocks and material where the fossils are embedded, and we can date them. It's not carbon dating. We don't use carbon dating for fossils necessarily that are that old, but we use different radiometric ways of dating the rock
Argon.
around the fossils.
Yeah, potassium argon is for anything in the hundreds of millions or billions of years. Carbon only goes for about 50,000 years.
Okay. And okay. But this is the other obviously with the movement of like the earth and stuff like that, how does one like differentiate from certain earth events that we don't know about could have happened that could have created an effect of this many years being added onto this, what I'm saying? For example, like volcano eruptions and things like that, and the earth moving
how
shifts
half-life
of
works.
platters and shit like that. You know what I mean?
No,
Over
that's not how
time.
isotopes or half-lives work.
Pardon?
That's not how half-lives or isotopes work. What
It is, 'cause
energy
when
you
you're
have
talking about layers
imparted
of
to
earth,
the
that's all
molecular
that
structure
does come into play.
is what's going to be shed in its dissipation over as many periods of time as it's going to be.
But that's
So
what
that's all
exactly.
going
That's
to
what I'm
depend on
saying.
the
Over
nucleus.
time, that stuff happens, isn't it? When we don't
No.
know.
No. That stuff happens in stars, not in planets.
The point is that you don't have enough heat for that to happen, and all the corroborating data points to radioactive dating being very accurate, and we can cross-reference with multiple data pieces, and we know it's accurate.
Effects in a planet, you're going to get those effects in the death of a star, and that's the only place those materials are produced.
No, we know it's accurate because they tell us it's accurate because those are the years that they give us, and then we get anchor years, and then we use those years to say, okay.
There's a method behind dating.
But the method is created a long time ago. That is actually, you know what I mean?
But it works.
It's been
but
set.
It still works.
I could say today,
You need
if
to
I
learn
destroy
about
the whole world,
isotopes, dude.
I could today destroy the whole world.
Sure.
Yeah. And then,
hey, do you know how
my name's
radiometric dating works? Do you know how dating works?
I know what you're saying, but let me hear me out. Yeah. Today.
No, how does dating work? How does radiometric dating work?
Let me land. Yeah. Today, if I destroy the whole world, and I decided that 1 centimeter is now going to be 2 centimeters. That's the standard. Now it's going to be everyone's going to be calling it 2 centimeters. Yeah. Does my 1 centimeter does it? Know what I'm saying?
No. You don't understand
when you change the anchor dates.
Dating works. Listen, there's a mathematical reason why we use dating, right? Because mathematically speaking, we know the average decay rates for certain isotopes. This is a mathematical certainty, right? So it's not like, we just go, oh, I think it's this old. That's not how science works. We look at the data. So maybe you don't understand the data. Maybe you don't understand the method, but it works. And if you don't like it, go try it yourself and prove them wrong. We don't care if we're wrong in science, so go prove them wrong. If not, what are you complaining about? Go learn.
No, I'm not complaining at all. Me, that's why I'm asking the
So
question.
what is the contention here? What exactly is the data that you have that debunks radiometric dating?
Because one, it's not consistent. They're not everyone actually, not all scientists agree with you actually in that, because one scientist will tell you one scientist is going to tell you this dinosaur is from this time, and the other is going to tell you another thing.
It depends on the sample.
You're out here saying it's like it's facts.
That's because people make
it's not
errors. Sir, that's because people make errors, right? The methodology doesn't make errors. It's the people that either make mistakes in what they're dating, right? There could be contamination in a given sample, leading to different errors that way. It could be a miscalculation. There are many factors that render their calculations wrong.
Not to mention that no square centimeter of any sample is going to be the same molecularly. You might have more amount of the isotope in one area than you have in another.
Okay, so now once we get to this base here of this millions of years, right, with dinosaurs, how does this changing of kinds from a monkey becoming a human come into play with that?
You don't understand evolution, sir. This is embarrassing. Evolution isn't like Pokemon where you go from Woolywog to Bollywog. It's genetic change. Hold on. Evolution is genetic changes over millions of years, but on a population basis, not an individual basis.
A
population basis.
There hasn't been enough discoveries to actually solidify that actually as factual. Like some people, some scientists obviously go with the Darwin theory. So they'll take a particular piece of evidence and see it as that.
Sir, no. If you just listen, I have the evidence. We have Australopithecus afarensis, one of the most common ancestors between us and chimps. We have Homo habilis fossils, Erectus.
There are many different types of chimps, but there's no proof that chimp was a human.
Oh,
sir,
chimps
share some DNA.
Humans are a different subset of species than the chimps, of course. But we have all the human ancestors, we have all their fossils, and we have our chimp ape ancestors in DNA record form and in fossil record form. We have human chromosome 2. DNA alone is proof of our common ape divergence.
Retroviruses, endogenous retroviruses. That is your smoking gun for evolution.
Listen, in the hand. Listen, this is my belief. I believe where there is DNA shared amongst all of creation that goes across, you know what I'm saying, throughout many things, you know what I'm saying, for certain abilities and you know what I'm saying.
Beliefs don't matter in face of knowledge, buddy.
Yeah, but that's truth actually. That's truth. There's many DNA. You could put a DNA into someone. We could do that like kind of with science right now. We could put a dog's DNA in a baby if we really wanted to. But what I'm trying to say is,
no, you couldn't.
That doesn't prove my DNA being in an ape's DNA does not prove that ape turning into human.
Yeah,
that's not,
because we are apes. So you don't recognize that we are apes now. You're not understanding that. You don't. And by the way, we don't just take one data point and say, aha, there it is. That's proof of evolution. We take a look at all the corroborating data, the fossil record, the analogous and homologous structure changes in fossil records. We take a look at all the DNA sequencing. We take a look at lab experiments like Linsky's in the 1990s, where he observed speciation. We have so much corroborating evidence that it would be silly to refuse the fact that evolution is a fact. It's a sign that you don't know how evolution works based on the things you just mentioned.
Yeah, there were 19 found discovered transitional humanoid to primate
species, not a change of kind.
Specimen.
I believe in a change of kind. I believe.
Sir, what's a kind? That's not a scientific term.
Okay, let me tell you this.
In his own little world,
a bird changing into different types of species. I understand that, to adapt and, to change from, you know what I'm saying?
Observe speciation multiple thousands of times in the fossil record, let alone DNA.
And that's just one modality of evolution anyway, speciation. You got 4 more that you need to observe as well.
I understand what you're saying, but this is my point is it's never been actually proven because it needs to be observable to be proven.
It
You know what I mean?
is. It's observable in
With
all
the
the
time that
evidences I just mentioned.
we've been able to observe changes of kinds and changes in terms of species
Yes,
species
we
changing,
have.
but
We
we
have.
have not been able to observe the change or at one species and actually confirming, yes, this
Are
species
you
is
silly?
definitely
We did. We have
We've
in
done it with
labs.
fruit
I
flies. We've
gave
done
you
it
a
with
list
slugs. We've done it with
because you're
snails. We've
saying
done it
because
with
some
mice.
scientists
We've done it with
listen,
types
let
of
me tell this.
dragonfly and
A scientist
damselfly. We've
saying
done it with
a
bacterium. We've done
T-Rex.
it with paramecium.
Okay,
We've
so
done it with
here,
amoebum.
How am
We've
I
done
gonna
it
here,
with.
believe you if a
hold
scientist
on,
is
guys,
telling
hold
me?
on.
Good Lord!
Listen, hold on. How am I gonna believe you if a scientist is telling me a
It's
T-Rex
not a
turned
scientist
into
telling you, sir. It's the
a
research that you
T-Rex
can
turned
go
into a
verify.
chicken?
Sir, listen.
T-Rex turned into a chicken.
Here, how about this?
That's science for you, bro.
Go. How about this? Go look up.
Over millions of years, a T-Rex turned into a
Sir,
chicken.
hold on. I know you're angry. Hold on. Go look up Richard Linsky's experiment in the 1990s with E. coli. Go look up that experiment, and then guess what? If you think he's wrong, prove him wrong. Okay? If
I'm
you
gonna
can't
go
do
research
that,
that.
you know what you went wrong if you can't prove it wrong. That's the point. Science doesn't care about authority. It doesn't care about you saying something. It cares about the evidence and the methodology. And that's it.
Yeah.
Yeah. Hey, little Dabby, what do you got?
Hi. How are you guys?
Good.
Good. Okay. Great. So your last guest, I think, kind of accidentally touched on something that I don't think that he was like consciously thinking about, or she, I don't know. Are you familiar with the philosophy of construction empiricism?
Yeah. What's your question today?
Oh, okay. You're so sassy. I was gonna get to it, but you just make me laugh too much. I was just wondering what your thoughts were on construction empiricism.
Okay. I don't know what construction empiricism means. I don't really care too much about philosophy.
Okay.
I care about science.
True. Yeah, so well, it is a philosophy that like pertains to science. Basically, what it states that is that like our current understanding of science is semantically literal, and the like the empirical numbers and things we've assigned to things for conversational sake are meant to be empirically adequate. So like Godkiller was saying, you could have one section of like some type of molecule and it's going to have like a slightly different makeup than everything else. So I think what your guest was kind of touching on was that, but not like a full understanding of what that means.
I think what you're talking about is a bunch of gibberish. It's just a bunch of blah, 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 blah. Science works. It works. And sure, there might be philosophers of science who, complain about certain things here and there. But science, the main idea, works. Scientists actually go out and do things. Philosophers sit in their chairs and complain. Scientists actually go out and do the work. So, any other questions?
No, not really.
Okay, thank you. Yeah, unfortunately, philosophy is a very pointless endeavor for many reasons. 99% of it is just gibberish. I care about doing something useful, right? Solving problems in the real world. Philosophy can't do that.
Outside the laws of logic, philosophy is basically useless.
All right, see if there's any other victims in here. They're all trolls. Everybody, please subscribe to the YouTube for more content. Can you explain metal fusing in space? It's called cold welding. In space, there's this static electricity that metals typically have that they weld together a certain way, and whereas on Earth it doesn't happen that way because of the air that gets in between. But in space, certain metals can weld together. What caused the initial singularity? Singularity is an idea that scientists are weaning off of. We now know better than relativity today. So
isn't the only operative either. Jumping back to the other one, once things get large enough, they will generate the heat just from the molecular friction. So their electroactivity will make the things that are most condensed by the gravitation a little bit more fizzy.
Ah, good point. Yeah. Are there only 51 galaxies in the universe? No, there are trillions of galaxies, trillions of galaxies at least, and that's just as what we observe. I mean, some scientists believe the universe could be hundreds of times bigger than that. What is the weak nuclear force? I'm not too exactly sure, specifically speaking, but I know it has to do with, I think, atoms, atomic states.
Yeah, but it's basically the way that the nuclei are going to kind of talk to each other. It's the weak force, weak nuclear force. It's kind of one of the weird ones in the four that we know about. It basically allows for neutrons and protons to kind of combine each other up. It's kind of like the way that molecules will be shared via covalent electrons or sigma electrons, the bonds therein, but it's not doing it with electrons. It seems to be doing it maybe we're thinking with either gluons or quarks that are inside of the neutrons and protons.
Right. I want to answer some comments now. Life cannot come from non-life. Well, sure it can, because life is not an object. Life is a process, right? Life is what non-life does. It's a process. It's a chemical process inherently. There is no object that makes you alive. What is the fastest thing in the universe? Light.
Yep. If we do discover that tachyons are real, then they become the fastest thing.
How do you make electricity with a magnet? Electricity is very tethered to magnetism, and it has to do with motion and coiling up something like a magnet, a certain motion. It can generate electricity that way.
Kind of think about how matter goes through different phases, right? Forces kind of seem to do that as well. So with water, you can have it in its gaseous stage, you can have it in its solid stage, ice, or you can have it in its liquid stage. You can also have it in its plasma stage, but you're going to have to start breaking up the hydrogen from the oxygen, et cetera, to get them to plasma. But anyway, it's kind of like the same thing there, except with the forces. So light, the electromagnetic force itself, and the electricity, they're all the same thing. They're all the exact same kind of quote-unquote molecule, but they're in different phases. So they'll behave in different ways.
Okay, do we have a scientific way to ward off a nuclear war? No, we're screwed if that happens. If Russia decides to nuke us, we're going into WW3.
I think we've got a very effective scientific way to ward off a nuclear war. Don't build nuclear weapons.
Right, yeah. Good point. If light is fastest thing, then how did the darkness get there first? The darkness is not it doesn't have ontological status. It's not an actual thing. It's just a lack of light.
Exactly.
Okay, we have a guest. Probably a troll. Why are there meteors tonight? Well, sometimes there's clusters of asteroids and rocks that will come by.
I think we've got the ass end of a tail of a comet, actually, which is what people might be saying. I think this is the weekend for it.
Hello, Waffle. How are you? What do you got?
Yeah, how are you? Good, thanks. I've got a couple of questions for you space guys. The first one, black holes. When I see a drawing or a diagram, it looks like a big funnel that curls in. If you could get behind that and look at it, would it look like the back end of a funnel?
Yeah, that's a great question. We have no idea what happens inside of a black hole. But a black hole isn't necessarily an object. It's more like a kink in space and time itself. If you were to look at it, you would see a spherical thing. It would be a spherical black thing. where like a kind of like a hole, but in all directions, in all three dimensions.
Got you.
But
Okay,
From
one second
within,
question.
an actual funnel.
Yeah, from within, especially down deep, you wouldn't see anything if you were trying to look out. In fact, once you're, according to the math anyway, what we're expecting, if you were the one falling in and you were looking out at the universe, when you pass the event horizon and actually fall in, you'll see the universe play out very, very quickly. And then from that point on, you're basically just in a non-stop well of light falling in down kind of path. Kind of think like an aurora of light falling, raining down on you, because you can't look back anymore. You can only look where you're looking, and that kind of happens forever. Unless you're in like a supermassive black hole, then you get spaghettified, and well, then it doesn't matter because you're not you anymore. You're just energy.
Can you explain quantum fluctuations? Well, very simply put, I don't know too much about it, but all I know is that there's something called potential energy, and it can be stored in these quantum fields, kind of like a self-interaction, right? Kind of like a string you pull, it interacts with itself, it vibrates. Well, this could happen on the quantum level, and sometimes due to the random nature of quantum mechanics, they can randomly fluctuate in certain ways that are strong enough to yield these inflationary particles that turn into the universe we know today. And that's what essentially it is, a quantum field that broke, and energy was yielded from that interaction. And that's what we think the universe is.
In fact, we have a pretty solid observation of this called the quantum foam. So if we make a vacuum chamber and pull everything out of it, so it's a quote-unquote perfect vacuum, and then we measure the charge that's occurring within the vacuum, we still see positive and negative charges, alpha and beta waves coming off of them, and then self-annihilating. So apparently coming from quote-unquote nowhere, and then going back to quote-unquote nowhere after they annihilate again. And they happen. We can't stop them. We can't catch them. We can't touch them. We can just see the ripples that they did.
Yeah, it's like fizzing these virtual particles. How to remove CMB though? What do you mean? You can't remove the CMB. It's everywhere. Quantum foam. Yes.
Yeah, exactly. Quantum foam. That's what's in the vacuum. Yeah. How would we even go about removing that? I'm just going to leave that one alone because that's nonsense.
If the universe, okay, there's two good questions here. Did the future already happen? Mind-boggling that time is a function of velocity. Well, time is not a function of velocity necessarily, but if from a four-dimensional aspect, right, looking down a 3D world, or from a five-dimensional aspect, looking down in a 4D world, 3 is space, 1 is time, all the time exists, just like all the space exists. Right? Just as you think stars are out there and they're there, they don't change. The same with time. Time doesn't actually pass according to relativity. That's an illusion. And all the time, the future, what we call the future, what we call the past, exists at the same time. Yeah, that's like if you ever saw Interstellar, that time where he was in the Tesseract, he saw all these different timelines, all the times, and that's what it would kind of be like. But yeah, it is mind-boggling that time is relative. Okay, if the universe is infinite, does that mean there's infinite copies of me? It's possible. Yeah. With an infinite universe, anything's possible.
That is a maybe. In fact, if it is truly infinite, if it is, it would be expected as well. Because at some point in that infinitum, yeah, your exact molecular and charge and magnitudes and your tensors themselves are going to be replicated perfectly somewhere else, not anywhere locally, obviously, but somewhere else. They would have to be in order to have a truly infinite potential there. But that depends on if it's infinite. We'll let you know when we can measure that.
Can you explain Hawking's chronology production conjecture? I'm not too familiar with it, but all I can think about is this idea that if you go back in time and you stop your grandma or you stop your mom from dating your dad, will you be born? And then they kind of like break the timeline thing, right? But I don't know if that's how time really works. There's
Right.
there's an idea that time forks, right? Like a river. It forks into two different timelines every time an event happens. So if you were to go back in time, you're not actually killing or you're not harming your parents' relationship. You're harming somebody else's in a parallel universe, a parallel timeline. I think that's what he was trying to talk about.
I mean, I was explaining the question that was asked, but sure.
All right, what's your question, Lucy?
No, Mike, I don't have any question. I just have something lovely to tell you, darling. I got to tell you, I have been following you as a Christian, as a,
Oh, that makes sense. Now I
all your
understand that
characters,
entrance.
all your characters. But I have a question. Well, you know what? In reality, I have a question. You always focus on the future, or in the past, or in religion, but I have never heard you talking about the present, which it concerns me because people follow you like if you are a god, and to me you are a human being that is boring and is trying to make money out of us. I understand that, but I have never heard you talking about what's going on in the Middle East, what's going on in our country, what's going on
The
in
reason
Latin
why,
America.
ma'am, the reason why
No,
is
ma'am,
because
you can call me Lucadero.
the reason why is because all that stuff in the now, all the stupid stuff in the media, all that, sure, there are problems out there, but the root of all those problems, the foundation to all those problems is many times belief in God. And people use their belief in God as the foundation of how they operate. So if I can shake that, if I can mend that a little bit and get people back on a better direction, then all the other problems will be finally solved. We're never going to solve the problems in the present if we don't fix the fundamental problems, right, about how we think and see the world. So that's why but the thing is that people don't like to talk about the belief in God. And I'm here to show you that it's okay to talk about God. It's okay. When I do all those characters, it's to show people that it's okay to leave religion. It's not a bad thing to question. And that's my job. I don't care about all the different stuff in the media. That'll come and go. But what doesn't come and go is how we see the world, our perspective of the world. That's hard to shake. So that's what I focus at. I focus at trying to shake the foundation of your entire belief system. This way, the rest of it falls down more easily.
Not to mention that war has been going on for longer than this country has even been around. Like they've been killing each other over whose sky fairy has the bigger peepee, since before your grandpappy had a grandpappy had a grandpappy. So, yeah.
Yeah. Religion has a lot to do with problems in the world today. That's the root cause.
Talking about that over on this isn't going to help. What will help is doing exactly what Mike's doing and helping people deconstruct and find a safe place to do so.
Yeah, and asking science questions. Asking questions about the world around you that defy your intuitions about it. That changes your mindset. When you recognize that things around you that you once thought operated one way, but now they operate a different way, that changes your mind in a way that that's amazing, powerful. So that's why I love science, because science is constantly on, in that endeavor of trying to change the world, trying to alter our entire trajectories and mindset. That's why science is great. Can you explain the great attractor? It's a big gravitational void. I don't know too much about it, to be honest, but it's a mysterious thing.
Yeah, none of us do.
Okay, I'm getting tired.
All right.
Yeah,
it's just a big area in space where things seem to be falling towards it.
Yeah.
But
how many dimensions
you have a good one.
All right. Have a good day, man. How many dimensions are there? Well, there could be, mathematically speaking, up to 11 dimensions. But we don't know what's possible. Do you think there's a possibility of an afterlife? Well, it's possible that life could be preserved forever, sure. But do I think there's something like a supernatural? No. I think the closest we'll get to an afterlife or living forever is perhaps quantum immortality, where there's a parallel universe where you exist on a different plane, but and that timeline never stops. I don't know. That's the closest I can think of to an afterlife. Why is the Earth the only planet with life? We don't know that, right? The Earth is one rock in an ocean of rocks. And we have barely looked out there. We've barely seen what's out there in the big ocean, right? We don't even know if there's life on Mars. It's the closest planet to us. Well, one of the closest planets to us. We still don't know if there's life there. Mars could have life. Enceladus, Titan, right? Venus, Jupiter could have life, right? We don't have enough technology yet to observe what's out there, right? But it's possible that life is common in the universe on some level. I hope you guys enjoyed. Everybody, please subscribe to the YouTube. My link in bio. If not, if the link isn't working, just type in my name on YouTube and subscribe. I really do appreciate it. Can you make a scientific case for morality? No, morality is not a scientific thing. Sorry you missed tonight. Well, I will have this tomorrow on YouTube. Do you think an infinite regression is possible? Of course it is. Loop, causal loop. A turns to B, B turns to A, B does A does B does A does B does it. Goes on forever. Are you excited about the Artemis missions? Yeah, I'm very excited to go back to the moon. Any space travel is exciting to me. Anytime we go to space, it makes me happy. Space is amazing. And the more we learn about it, the better. Space is the key. All of our answers are out there. Yeah, 4K footage. I'm very excited for that. The Earth is not hollow. we would not see what we see, right? We can measure the Earth's crust and mantle by looking at the earthquakes, looking at seismographs, satellite data. We can look at gravitational anomalies in the Earth's surface. Satellites have changed the way we see the Earth. Thoughts on SpaceX Mars exhibition? It's great. I love going. Guys, whoever, if you want to go to space, I'm with you. That's a great, great adventure. That's a great, great endeavor. People are so focused on Earth, right? Earth is great, but look at what's out there. There's a lot to discover. Everybody looks down too much on the Earth, but let's look up sometimes. It's the whole universe waiting to be seen.